Okay, everyone, so example 4 and 5, we are going to be talking about the roots of the polynomials, which roots, zeros, and x-intercepts all mean the same thing. Okay, so if you ever hear any of those words, we're talking about the same thing. So the roots, you guys, are the x-intercepts, and that is where the graph smacks the x-axis. So if I'm looking at my first graph, okay, which I just kind of drew a picture of a rough sketch of the graph you saw in the Prezi. If you want to make it more accurate, that's fine, but it really doesn't matter. It doesn't serve a purpose for the problem. Okay, so on the graph, we want to know where it touches the x-axis. Okay, which I spot one here, and I spot one here. So we're going to talk about how many times it touches the x-axis, which that is the number of real roots on the graph, because real roots you can actually see. Okay, and remember, you guys, the amount of real roots and imaginary roots, when you add them together, okay, that should equal the degree. So we're first going to spot all the real roots, and after that, basically it turns into a subtraction problem. You take the degree, okay, and subtract it by the real roots, and you get the imaginary roots. Okay, so let's talk about how many real roots it has, how many imaginary roots it has, okay, which they should add up to equal the total amount of roots. Okay, so in this, first of all, you guys, this is a degree 3 polynomial. And remember, the total amount of roots should add up to the value of the degree, which the degree is 3. So my total when I should get done is 3. Okay, so let's see what happens. Alright, so we need to count how many times it touches the x-axis, which this is slightly misleading, so be careful. It appears that it only touches it twice, right here and right here. But if you remember from the Prezi, okay, whenever the graph kind of comes down and bounces off the 0, do you guys see this one? It comes down and it like goes boing, it bounces off. See how this one is different than this one? This one actually crosses through the 0. It doesn't touch it and bounce off of it. Now, anytime a graph touches it and bounces off the 0, that is called a double root, and it counts 2 times. Okay, so since this one comes down and bounces off like so, this one counts twice. Okay, so this right here counts as 2 real roots. Now this one, since it just crosses on through, counts as 1 real root. So we have a total of 3 real roots. Okay, remember, all the roots together should add up to equal 3. So I need to think 3 plus what gives me 3? Well, 3 plus 0 gives me 3. So since there are 3 real roots, and I'm only supposed to have 3 total roots, that means this problem has 0 imaginary roots. Okay, and that's it. So I have 3 real roots, and I have 0 imaginary roots. Awesome. And that's it, you guys. That would be my answer. Yay! My answer. Don't overthink it, you guys. Okay, let's move over to this one. So, again, we are going to determine how many real roots there are. So the real roots plus the imaginary roots should add up to the total amount of roots. Okay, so I'm going to start by labeling the total amount of roots. So this graph right here shows some sort of degree 4, which is called a quartic. Okay, and a degree 4, remember, the total amount of roots should equal the degree. So since this is a degree 4, this will also equal a 4. Okay, so now I need to figure out how many times the graph touches the x-axis, and I must be on the lookout for double zeros. So I see that the graph smacks the x-axis right here and right there. Bam. Right here and right here. Okay, so if you guys see, the graph crosses through this one, so this one only counts once, and the graph also crosses through that one, so it also counts once. Do you guys see the difference between all the ones that cross through versus bounce off? Okay, if they bounce off like that, that is called being tangent at the 0, and if it does that, it counts twice, which none of those were tangent at our 0. Okay, so we have a total of 2 real roots. Okay, and remember, the total amount of roots needs to add up to 4. So I need to think 2 plus what gives me 4. Holy hot dog, you guys are so smart. It is 2. Okay, so it's basically turning to addition or basic addition or subtraction problem. Okay, so my final answer would be 2 real roots and 2 imaginary roots. That's it. So you have 2 real roots and 2 imaginary roots. Holy hot dog. That's it, you guys. Do not overthink the problem. That would be my final answer. Bam! That one is done so.